Hey guys, this tutorial will be using Gaussian and an external program called Kinisot, and here I want to show you a lazy way to compute the kinetic isotope effect. So to start off, we're going to be using a very simple reaction. It's the hydrogen abstraction from methane by a chlorine atom, a radical. So my reactants look like this. The distance between the radical and my hydrogen is about 2.1 angstrom. And I also have calculated the transition state, which for me looks like this, with one imaginary frequency, and the distance between my radical and my hydrogen is 1.4, and between hydrogen and carbon is 1.6 or so. So that you can use those distances for your initial guess. Now I will just quickly show you how my input looks for Gaussian. I'm using B3lib and a fairly large basis set. For the reactants, I'm using just optimization and a frequency calculation after that. And for my transition state, I'm using optimization of a TS, and I'm calculating the force constants only once. It's a fairly small system, so it all works perfectly fine here. Notice that I have a charge of 0 and a multiplicity of 2, since my chlorine is a radical and it has 1 unpaired electron. So now, once you have calculated your reactants and your transition state, we can go on using the Kinisot program to compute the kinetic isotope effect values. So this program is obtainable for free for everybody on GitHub, and I will link the URL in the description of the video. Or you can just Google Kinisot and you will probably hit the right thing. To download the program, you will click here on the green button, clone or download, then download as a zip, and then unzip the folder wherever you want on your computer. It doesn't matter whatsoever. The program was developed by Professor Patton. I hope I say it right, I don't know. And it says that originally it was made by Henry Erzeppa, which blog is actually fantastic and really interesting to read. So if you have some time on your hands, I would definitely recommend taking a look at this gentleman's blog, which I will also link in the description of the video. So this is the Python version of this program, and it currently can look at the isotopes of hydrogen, carbon, and oxygen, but it says that you can actually modify and add other isotopes in here as well manually. So if you're not afraid of changing the code slightly, you can go ahead and do that. It even says where you have to do it. Once you have downloaded and unzipped, your folder will look like this, minus the two .out files that I have copied in there. So you have the init.py, the has2 frequency, the Kinisot, which is the main program, and the vib scale factors. So to run the program is very straightforward. First, let's look at this example over here. You call the program's name, then you give the reactants name, the transition state file name, then you use this keyword -iso for isotope, and then in quotation marks you can write the atom numbers of the atoms that you want to change into isotopes in your calculation. Optionally, you can also change the temperature using the -dat and then putting the temperature value in Kelvin. The default one is 298 Kelvin as usual. And you can also change the scaling factor for the vibrations if you know what you are doing. the program also assigns the scaling factor automatically if it can figure out which basis set you are using. If not, then you can just leave it as 1, and if you know what this is, then you can change it yourself. Oh yeah, I also forgot to say that in the atom numbers you can put more than 1 atom. Then you would put them still in quotation marks, but just have a space between the atom numbers. So we are looking here at atom number 5, which I want to replace by a deuterium, and see how this will affect the rate of the reaction, and from which will be the kinetic isotope effect will be calculated. To call the program, I kind of made my life simple because I copy pasted the Gaussian .out files for the TS and the reactants within the Kinisot folder. If you don't like copy pasting, you can just write the path to Kinisot from your Gaussian folder. I was just a bit lazy with typing. To open a console, you can right click in your Windows folder and then click on Open Enhanced Console here. I already did that before. So to run for Windows, usually you actually have to type Python before you call the Python program. And then write kinisot.py, name of reactant file, name of transition file, and then I'm looking at the isotope of hydrogen number 5. When I'm done typing, I just press on enter and I obtain my output. So here you will see that it says unable to find vibrational scaling factor, probably because I'm using an open shell calculation and it doesn't find my basis set. I don't know, so it's using a scale factor of 1. I could change it to something else if I wish so. The description of all the entries of this output table is very thoroughly presented here in the example, so I'm not going to go through all of that. I encourage you to read the explanation over here. It's very straightforward and nicely explained. So what else have we gotten? Oh yes, important a message for people who are using an old version of Gaussian, like me. If you try to run Kinisot and you see an error like this, list out of range, couldn't split, or like this, Kinisot could not find level of theory, etc., etc. This means that when Kinisot was trying to parse your .out files for reactants and transition states, it couldn't do it properly. And this is because in older versions of Gaussian, the last block of the condensed block of data is separated by vertical lines like this. In newer versions of Gaussian, the last block of data, this is basically all the condensed results that you've got at the end of your file, right? If you scroll all the way to the bottom. In newer version of Gaussian, they are separated by backslashes like this. And Kinisot uses this separator to parse the results. So if you're seeing errors when you try to run Kinisot for the first time, that means that you will need to add 2 very simple corrections to your files, the Kinisot files. The first file that we will change is the kinisot.py. To change the code, you need to open Kinisot in, let's say, Notepad++. Okay. When you've done that, you can go to line 106 in kinisot.py and you would see this for loop that I have right now in orange because I commented it out. Okay, if you pay attention, you will see that your main separator is a backslash over here. So you would need to change it to a straight up line like I did here. You need to do it in 4 places: here, 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 and here. Once you've done that and your code looks like mine, you can save and close. You probably don't need to keep this part of the code because it's not going to be used. You can actually delete it and nothing bad will happen. So this is the first place where you have to make a change, and the second place is in this file over here, has to frequency. Same thing, you can open it in Notepad++ and go to line 55. And on line 55 you should see something like this. Here the same thing again. In the split section, I have replaced the backslash by a stand-up straight line. And then I save and close. So now everything will work no problem, and you can write your Kinisot and get your kinetic isotope effect value. So that's it for this tutorial. Let me know if you want me to do the like show an example of the classical way of calculating it using an equation instead of a program to make your life more difficult. So we'll see how people react, and if not, then I have a very long list of things that I would like to show you. I'm just very short on time, so be patient and I'll see you next time.